Welcome to Programming with Qt Widgets. I'm Jesper Petersen from KDAP. Last week we talked about the Qt's object model. We saw the parent-child relationship. We saw that the object model was the foundation for stuff like signal slots and the property system in Qt. This week we will enlarge our hierarchy by looking at Qt Widgets, which is a subclass of QObject. As we saw in the last episode, QObject indeed has a very important role in the whole Qt framework, but you seldomly new up instances of QObject yourself. What you new up is a subclass of QObject. So there's one very important one, as we can see on the screen here now, namely QWidget and QWidget subclasses. So you will often new up a QPush button in your user interfaces, or a QTextEdit, or some of the other QWidgets. But as we'll see on the next slide, you'll also often create instances of QWidgets themselves. So what does QWidget itself do? What does that class do? Well, it has a number of virtual methods. So it acts on the events that comes in through the event queue, as we saw in the very first episode. In there, it will act on event like mouse event, key event, so mouse press and mouse release and so on. We'll see that in a few episodes when we talk about the event handling. It will also act on another event, one that is called paint event, and that is how a widget gets a chance to paint itself. So when you think of a checkbox, it has a rectangular area that is the area you can check in, and it has some text. And you can think, at least conceptually, that the paint event of QCheckbox draws a rectangle and draws a piece of text. In reality, it doesn't. It does that via the styling system, but at least conceptually. And if you were ever, and you likely are, to create your own widget, you will definitely draw stuff in your own paint events. So that's part of what QWidget does. But in the context of the QObject hierarchy, it does something else. But for us to understand that, let's draw a small widget hierarchy, not as in its inheritance, as you see on the screen here, but as in parent-child relationship. What you're looking at here is a QDialog, and a QDialog obviously has some stuff in it. Here's a checkbox, here's a QLabel, and a QLine edit, and obviously it also has an OK button. Ooh, sorry, I forgot. My handwriting is so ugly that, well, let me fix it. There we are. And the whole dialog here, there's a pointer to that. So let's just call that pointer dialog. So we saw QWidget in a different role here. Of course, what we really saw was QDialog, but it could have been a QWidget. And sometimes you don't care about it being QDialog. You'll just have a QWidget. And the role here was that it was the parent of a number of other widgets being laid out inside of that dialog. And that's the other part of the parent-child relationship in the QObjects, or in the QWidget part of the QObject hierarchy. So what we saw there was that children was laid out inside of their parents, and the coordinate system. So the checkbox, if I were to lay it out manually, I would move the checkbox to a coordinate system that was a number of pixels from the left side, that's the X coordinate, and a number of pixels from the top, that's the Y coordinate. And I would take my pixel ruler, I'm sure it would look something like this. I would take it up and I would measure that, yes, that's gonna be 10 pixels from the top and 20 from the left. And I would move it according to the topmost, leftmost part of the dialog being 0,0. So the coordinate system of the children are according to the parent. They also clipped, and let's get back to my drawing here for a second. So imagine that I was laying out manually without layout managers, and we'll see layout managers, I swear, in a few seconds. But if I was moving my widgets myself, I could take an OK button and I could move it to the bottommost part of this dialog that we're looking at here. And imagine that my OK button was standing right down here and saying OK. But what's part and is important to understand in QWidget is that the children of a widget are being clipped to the area of that widget. So the dialog border here of the widget would be what would clip my OK button. And therefore, what I would see on the screen would look much more, well, give and take, like this. If you're a seasoned C++ developer, you likely have heard about ClaineTidy. But how about Clacy? Clacy is a tool for identifying best practices with Qt. Well, whenever Clacy says something, it's because you haven't followed the best practices, or because you're doing something that is not as safe as it should be. Clacy was developed by one of the KDAP developers, Sergio Martins, so thank you very much for that, Sergio. Back to the black and white, Jesper. There's one more thing on the parent-child relationship of widgets, and that is propagation of events, or certain events at least. So first of all, if you hide or show something, then all the children will be hidden and shown together with it. It would be really weird otherwise, wouldn't it? Imagine that you had a dialogue and you hit the dialogue and all the decoration of the dialogue would go away, but all the children would still be on the screen. Showing a dialogue, it would be similar weird if all the children would not be shown, but only the decoration of dialogue. But there's a catch to it. If you have shown something, say a dialogue, and you add a child to the dialogue later on in reaction to the user pressing a button, for example, and you then create that child of the dialogue, then you need to show that at that time, because it's only as part of running through or showing the dialogue, it will run through the list of children and call show on each of them, and it won't happen later on. The other thing is enabling and disabling of the dialogue, and that's again, or of a parent and its child hierarchy. And that again would be really weird if you had, say, a group box and you disable the group box and its decoration would be disabled, but all the children would still be enabled. So if you called disable or set enable false, which is the method that you call on a group box, then all the children will be set enabled false too. Then if you call set enabled true on it, then all the children will be set enabled true, except those that you have explicit gone and call set enable false. So imagine you had a group box with 3 checkboxes. On one of those checkboxes, you say set enable false. Then on the group box, you say set enable false. And then on the group box, you call set enable true. Then all the children of that group box will be enabled except that one checkbox that you explicitly called set enable false on. Again, you might not even think about it. It just comes naturally. A few minutes ago, I promised you that in a few seconds I would show you layout management. So I'm already overdue now. So let me show you what a layout manager looks like. It looks like this. I won't even try to draw it as a circle because I will fail at that. So it's something that is not a rectangle. That's the key thing here. A layout manager is not, I repeat, is not, let me repeat one more, is not a widget. I've seen many people try to make children of a layout manager. And you cannot do that because a layout manager is not a widget. You can make widgets children of widgets. What happens is that you associate a layout manager with a widget, and then whenever the widget needs its children laid out, in, for example, its show event, it will go to the layout manager and say, can you please do that? So it will, the widget will call upon the layout manager. I'm sure that there is a fancy method for doing that. And the layout manager will go back and ask the widget for which children do you have? Oh, you have that one, you have that one, you have that one, you have that one, and then it will do its work moving and resizing the widgets on the parent widget in place. Let's see some code for all of this. I will show you a piece of code that is much more realistic than the first piece of code I showed you, and it looks like this. But first of all, observe the result of the code. I have a dialog here now. I'm not even sure it's a dialog. It's likely just a Q widget. It has a label here. It has a Q text edit. It has 2 buttons in here. And what makes this code much more realistic than the first one is that in the very first example, I committed 3 sends. And I've been sleepless for many nights since I did the recording of that, because I forgot to tell you that I did these 3 sends. So let's just see the 3 sends I did. First, I had all my code in main.cpp. Of course, you're not going to do that in your real applications. You are going to have your code split out in multiple files. But I tried to do that in this training here simply because it's easier to get an overview of everything if it's just in one file. Second, I included Qt widgets. It wasn't even called .h, just Qt widgets. That include file is include of everything that is Qt widget, and that makes your compiler hard at work. So unless you have pre-compiled header support set up, and maybe even then, you should never call or include Qt widgets. You should include separate ones. As you see here, I include Q application because that's the only one I use here. And the third sin that I did was that I created my widgets on the stack rather than using new. And I do that sin still here because that's okay in main.cpp, but when you get to it in real life, you should never do that. So let's see what it looks like here. My symbol window is a Q widget subclass, and this setup of one class for every major UI components you have is a pattern you'll see quite a bit in your widgets application. It has a constructor, and in the constructor, that's where I'm setting up my whole user interface. And again, you can see I include just what I need in here. And here is my setup of stuff. I create my label, I create my text edit, I create my push button, and I create the other push button. And each of those are then laid out, which I do here. I create a layout manager. I have 2 layout managers I use often. I have QBox layout, QHbox layout, and then I have 2 others that I use slightly less often, QGrid layout and QForm layout. And if you come from if you come from a Motif background, a form layout is nothing like what you have in Motif. But I'll get back to the layout managers later in this video series. My VBox layout here, I create an instance of that and I add widget, the node label and the node edit. And let's see if I can find my dialog up here again. There it is. This is my outer layout. That's a vertical layout manager. It adds the node label and the node edit. That's the node label, the node edit. Then I create an inner layout manager here. And the inner layout manager is a horizontal one. And I add the clear button, I add the save button. That's the clear and the save button. And then I, to the outer, add the inner layout manager. And when I'm done with that, I add the whole shebang to my widget as a layout manager. Observe all the thises, trying that at home 10 times in a row. This, and this. These are the parent. So I go here and I look at my Q widget. Now I'm in QLabel.h here, and I look at the constructor and see QLabel takes a label here and a Q widget parent as the parent. And that's the parent that we have here. On the way out here, let me just redo this code slightly because I would never write it like it's stand here. It's too top down for me or bottom up for me, creating all the widgets first, then adding them to the layout manager. That's not how my brain works. I will be thinking, okay, that widget should go to that layout manager. Let me create that widget and put it into that layout manager as I go on. And the code looks like this, and it will produce exactly the same result. And first of all, when you look at this, what are these braces doing? Absolutely nothing. It's just to give you the feeling of that inner scope that we have there. But anyway, I will start out saying, let me create a layout manager for the whole shebang. That's the one we have up here. Then let me create the node label and take that node label and I'll put that into that layout manager that I have right away. Also the node edit, add that to the layout manager. Now I need a layout manager that is horizontal. So I'll create my horizontal layout manager and I will add a clear button. I will add that to the layout manager there. I'll create I'll add a save button. I'll create that. And instead of this layout, or this set layout outer, what I can do simply is that when I create my layout manager, I can specify the parent. And that means that now the layout manager knows that it's working for that particular widget that is this, and it will listen to the children of that and lay them out. It would be awesome, wouldn't it, if I could also go down here and say my inner layout manager actually should be working for my outer. If I spell that, outer. But unfortunately, that doesn't work. It has puzzled me for, I don't know how many years by now that it doesn't work. But for that, I still need to go up here and say outer add inner. And now you can see that all of this code here, there is no code left. I personally, delete that one, find this slightly clearer. And I can even make an additional change here. I can remove these thises here, there, and this, whoops, wrong delete button, and this one, slightly clearer. Now I can see I'm creating a label with node. I'm creating a text edit. I'm creating a push button that is called clear and another Q push button that is called save. And the reason why this works is that when I have a layout manager working for a widget, then as soon as I say outer add widget node label, it will say, okay, so you are now being laid out by me, which means that you better be a child of the parent that I am working for. So it will go to the widget that it's working for and say, hey, you should have this as a child, because it wouldn't make any sense otherwise. Remember the button, the OK button that was clipped off the screen? If it had another parent, I couldn't lay it out inside of my widget. So I need to have that set up. I like this code better. It is, and let me just run it here so you can see it. It is really potato, potato. Which one you like the better, but you have both options. I'm sure there's only one question left here unanswered, and I'm sure you all sit with that question just waiting for me to answer it. And I'm sure that it goes like this. Hey Jesper, you've shown us that you can have children of that simple window and they will be laid out inside the simple window. But what mechanism is there for the simple window to show up on my screen? Do I need simple window to subclass something, or do I need to have a bunch of special macros around my simple window class to make it a top level? For that, let's look at the code. Here I have simple window and window.show. So to bring it up, I call show on the simple window. But let's look at what does the simple window look like. It itself is inheriting from QWidget, and the constructor takes a parent, like all the other constructors. Parent equals a null pointer. And I did not specify a parent in my main.cpp. So when I create a QWidget subclass, or a QWidget itself is okay too. If I create one of those and I do not give it a parent, so parent equals null pointer, then it will be a top level. It will be decorated by your desktop system. It will be a window that you can drag around in and everything. Nothing more is needed. Doesn't need to subclass from a Q top level or Q dialog. We do have Q dialog, but that's for a different purpose. That's about modality, and we'll talk about that later in this training. All you need to do is to create a QWidget or a QWidget subclass and not give it a parent, then it will be a top level. That's it. It got slightly longer than I anticipated, so let's just recapture what we saw. Actually, in the previous episode, we already saw the QObject class and its parent-child relationship. We saw that we have a QWidget that is a subclass of QObject, and that the QWidget itself is reacting to a number of events like pinged event and mouse events and so on. But also, we saw that the Qt widget goes into a parent-child relations hierarchy, and that it meant that it would be clipped to its parent, it would be laid out in the coordinate system of the parent, and we even got so far as to look at a simple layout where we saw that this pointer be given to the parent to add to it, but we also saw that it would actually work implicit behind the scenes as long as I had the widget added to the layout manager and the layout manager working for some widget. That's it for this episode of Programming with Qt Widgets. The next episode, we're gonna be starting our descent into understanding the signal slot mechanism. So stay tuned for that. Until next time, have a great time.